we want to know the voltage across each and every capacitor in this circuit. It's fairly easy. We just have to take it one step at a time. So first off, we want to know how much charge is stored across all these capacitors all together in the circuit. So in order to do that, we find the equivalent capacitance of the entire circuit. These two are connected in series with one another, so we can combine them. So let's call this the equivalent C1, and that would be C1 would be 1 over 60 plus 1 over 30. This would be equals to 20 microfarads. So these two together can be interchanged for a 20 microfarad capacitor, and then we can add these two together, this 20 microfarad with this 20 microfarad, because they are in parallel with one another, and that will result in a capacitor C2. 20 plus 20, which will be 40 microfarad. Then 40 microfarads plus 40 microfarad. They are in, that will be our equivalent capacitance, and they are going to be in series with one another. So we're going to have 1 over 40 plus 1 over 40. That would give us 20 microfarads. 20 microfarads. To make it easier to visualize, I drew it out like this. First of all, we combine these two and it gave us C1. Then we combine these two and it gave us C2. Then we combine these two and it gave us C equivalent. Then the next thing we want to do, now that we have the value of the equivalent capacitance, we want to know the total charge stored in the circuit, and that would be Q is equals to CV. So that would be 20 times 10 raised to the power minus 6 multiplied by 60. That would be equals to 1.2 millicoulombs. Okay, 1.2 millicoulombs. So we know that the charge across these two capacitors is the same. So 1.2 millicoulombs here, 1.2 millicoulombs here. Then we want to know the voltage across this. So Q is equals to CV. That means that V is equals to Q over C. So V1 would be equals to Q over C1. Okay, so that would be that 1.2 times 10 raised to the power minus 3 divided by 40 times 10 raised to the power minus 6. That would give us a value of 30 volts. So we know that V1 is 30 volts. Then we also want to know the voltage across C2, and we know that C2 is 40 volts, so the calculations here are essentially the same. We'll get 30 volts again. So we know that V2 is the voltage across this 20 farads capacitor, 20 microfarads capacitor, and this C1. So we know that V2 is equals to Q over C2, which would be equals to 30 volts. Now we know that the voltage at this point is 30 volts. So it's a good idea to calculate the amount of charge is across V1, across C1, and that would be Q. Let's call that Q1 is equals to C1 times 30, which would be equals to C1 is 20 microfarads, multiplied by 30, and that would be equals to 0.6 coulombs. 0.6 coulombs. Sorry, I meant 0.6 millicoulombs. Yeah, that should be it. And then we can then proceed here. And we will know that V3 would be equals to Q1, because this charge is charge is the same as the charge across this capacitor C1 is the same as the charge across this capacitor, and charge across this capacitor. Q1 multiplied by 60 microfarads. That would be 6 times 10 raised to power minus 4 multiplied by divided by 60 times 10 raised to power minus 6, and that would be 10 volts. And in this case we would have V4 equals to Q1 divided by 30 microfarads. So that should be around 20 volts. Yeah, and we have successfully calculated the voltage across each capacitor. See you next time. Bye.